So I am continuing with the final exam review. This is problem 21. So 21 asks to sketch a graph of the function f of x is equal to cosecant. So you may remember cosecant is 1 over sine of x. So the first thing I'm going to do is figure out where cosecant has an asymptote. So that's just wherever sine is 0. And I know that sine is 0 at 0, so I'm going to start there. So I've got sine of 0 is 0. And then I know that sine of pi is 0. And sine of 2 pi is 0. And then the same thing will happen at negative pi and negative 2 pi. So then from here, I'm going to plot some points. So let's see. It's not drawn in, but pi over 2 would be right in the middle. So I'm going to start there. Pi over 2, sine of pi over 2 is 1, which means cosecant is also 1. And then sine of, well, it's actually sine of, the easy one is sine of pi over 6, because pi over 6 is this guy, where the sine is 1/2. So pi over 6 is right here. 1 over 1/2 is going to be 2. So that happens on the other side as well. If we do 5 pi over 6, same deal, just quadrant 2. Sine of 5 pi over 6 is 1/2. That means cosecant is 2. So it looks like this. And then I know that cosecant is going to do the same thing but negative in the next section. So it'll be here, here, and here. Same deal. And then back over here, it just repeats itself. So it's this exact same thing. And then same deal over here. Here, nope, here, here, here. And there we have at least 5 points and a pretty good graph of cosecant. So next we're asked to sketch the graph of cotangent from negative 4 pi to 4 pi. So again, cotangent, I'm going to rewrite it as cosine over sine. So if cotangent is cosine over sine, actually, conveniently, sine is the denominator again, which means it has all of the same asymptotes as this guy. It's got an asymptote wherever sine is 0. Oh, you know what? It's a different graph, so I still am going to have to draw it, but same exact asymptotes. So it's at 0, pi, 2 pi, and so on. So let's draw that. 0, um, and then we've got pi, and then 2 pi, and so on. Because it's got an asymptote wherever sine is 0. Sine is 0 at all these places. So that holds true of negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. Okay, then let's see. I want to know where cotangent is 0, because 0 is pretty easy. So it's 0 whenever cosine is 0. So cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Same thing in the negative direction. It'll be 0 at all of these places. Then I just need to know kind of what direction it goes. So I will figure out where it's equal to 1. Cotangent is 1 at pi over 4, because at pi over 4, sine is equal to cosine. So that's halfway between, that's right here. It's also equal to 1 over here. Same thing in every cycle. Like this. And then I can do it on the other side as well. And then let's see, cotangent is negative 1 at 3 pi over 4. 3 pi over 4. So that's right here. And it repeats itself as well. Here, 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 and on the negative side as well. Okay, then I just draw the rough shape and I've got it. So cotangent looks basically like this. And I can just copy and paste that shape a few times and I will have my answer. It's not the most perfect, but as long as you plot the right points and you have the general right shape, it should be fine. Yeah, that should do it. Okay, 23 says use the graph of tangent to determine all of the values x at which tangent is undefined from negative 4 pi to 2 pi. Well, I know what the graph of tangent looks like. It looks like this. Well, that was sloppy. It looks like this, and it's got asymptotes, and the asymptotes I know are at pi over 2 and negative pi over 2, so I'm going to start there. Pi over 2. And then I know it repeats itself, and the period is pi. So all I have to do is add pi to find the next asymptote. So if I add pi, I get 3 pi over 2. And if I do it again, I get 5 pi over 2. Then if I did it again, I would get 7 pi over 2, but that is bigger than 2 pi. So I'm going to ignore 7 pi over 2. To the negative side, it's negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, negative 7 pi over 2. And I can keep going because this says go all the way to negative 4 pi. So let's see, that's also negative 9 pi over 2. And there I should stop because that is bigger than negative 4 pi. So this would be my answer. I just realized 5 pi over 2 is also too big. I shouldn't have included it. Should have stopped a little sooner. 3 pi over 2 is correct, though. This is a better answer. There we go. Those are all the values at which tangent is undefined. Okay, number 24, we're going to sketch the graph of 2 sine of 2x from 0 to 2 pi. So I actually notice right away that this means the amplitude is going to be 2. And this graph is not correctly labeled for that, so I'm going to change it so that it is easier to draw. There we go. So if the amplitude is 2, it's going to look like that. AKA, that's also known as a vertical stretch by 2, so I'm going to label that. Vertical stretch by 2. And this guy right here is a horizontal. And horizontal is always backwards, so it's a horizontal compression by 1 over 2. So that means I'm going to take my original sign, and my original sign looks like this. It starts 0, goes up to 2 pi, down to pi, negative 1, back to 2 pi. Here's my original sign. But my original sign is going to be compressed. So I usually like to start with my parent function. Here's my parent function. Then I need to, I forgot. This is actually the parent function. There, that's the parent function. Then I need to do two things with it. The first thing I'm going to do is I'm going to horizontally compress it, which means I'm going to take it and move it in like this. So instead of pi, it'll be pi over 2, and then this bit will end up at pi. So see how that is now, it repeats itself twice as fast. It's been compressed horizontally. I just divided every x value by 2. And then finally, I need to do the exact same thing, except I'm going to stretch it vertically by 2. So I'm going to take this guy, stretch it to negative 2. This guy, stretch it to positive 2. This guy gets stretched to positive 2. And this guy gets stretched to negative 2. And I should probably color that in some way to make it clear that it is my final answer. But that should do it. Perfect. So again, it's been horizontally compressed by 2, and it's been vertically stretched by 2. And that's it. Okay, identify the amplitude and the period of this graph. So I'm going to start with period because that's harder. The period is 2 pi over b. And in this case, b is the number in front. B is always the number in front of x. In this case, it's 2/3. So it's 2 pi. Instead of divided by 2/3, I'm going to be doing multiply by 3 over 2. If I do that, I notice my 2's cancel, and I get 3 pi. So my period is 3 pi. Then my amplitude is pretty easy to see. The amplitude is just the number in front. In this case, it is just 2. Okay, number 26 asks us to graph negative cosecant x minus pi over 4 plus 1. The first thing I want to do is graph my parent function. So I did this earlier, but cosecant is 1 over sine, which means it's got an asymptote whenever sine is 0. So that is at 0 for 1. It's also got an asymptote at pi, and it's got an asymptote at 2 pi, then again at 3 pi, and 4 pi. And then it's the exact same thing in the other direction. It's got all these asymptotes at negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Perfect. Okay, then I know that, let's see. Sine at pi over 2 is 1, which means cosecant is also 1. So my parent function will look like this. And then I don't need to be super exact beyond that. I think that's sufficient. It's this shape, and then this shape. And then I'm just going to copy those and keep them going in both directions because it does that multiple times. So again, this is the parent function. So then a few things happen to my parent function. Well, let me finish drawing my parent function first. There we go. That's the whole right side. And the left side. Okay, we are good. A few things happen. First, it gets shifted to the right by pi over 4. So this is a shift right by pi over 4. Then it gets flipped upside down or reflected vertically. Reflected vertically or across x-axis. And then it's going to be shifted up 1. So first thing I'm going to do is take the whole thing and I'm going to shift it right by pi over 4. So that's about it. It's shifted right by pi over 4. And I will make it green. There we go. Then the next thing I need to do is reflect it across the x-axis. So it'll be the exact same thing except everything's going to get flipped upside down. So I'll just draw that brush. So this guy right here will become this guy. This guy here will become this guy. The next one will become this guy. And the green lines are my new asymptotes, in case that wasn't clear. This one. Not the cleanest graph I've ever drawn, but it'll be okay. Hopefully you can see the green graph is literally just shifted to the right by pi over 4. And the blue one is just everything's upside down. Okay. Finally, the last requirement is everything is going to get shifted up 1. So Um, there we go. Shifted up one means it ends up right here. And then make it bigger to be clear that that is my final answer. So that happens a few times. Here, here, here. Is that shifted up one properly? No, it's not. I need to shift it up more. This is shifted up one. There we go. This is shifted up one. This is shifted up one. That's correct. And this is shifted up one. And then down below, do the same thing. Just I'm going to make it purple and bigger. That is also shifted up one. Shifted up one. Shifted up one. Um, and the purple graph should be it. What I can also just do is make my final asymptotes bigger. So my final asymptotes were the green ones. Change them to the right color. So I always do my asymptotes red. And we will have our final answer. Thick lines. Whoops. Okay, and that should do it. The purple and red are the final answer. Okay, next up, find the equation of the graph below. The first thing I notice is that this looks like a cosine because it starts on the top and then goes down. And then I like to deal with period first. So the period is equal to, well, it starts at negative pi over 3 and it ends at 5 pi over 3. So if I do 5 pi over 3 minus negative pi over 3, I get 2 pi. And the period is always 2 pi over b, which means b is 1. So this will just be an x by itself because the period is not changed. The period was 2 pi, the period is still 2 pi. Nothing's in front of x. But the graph has been shifted. It's been shifted left by pi over 3. So I'm going to put plus pi over 3 to indicate that it's shifted to the left. Finally, I know that the amplitude is a half, which means a half goes in front, and the midline is still 0, so it hasn't been shifted up. So this is the final answer. Okay, for this one, same instructions. What jumps out at me is that it looks like a sine. And then I'm going to again start with the period. So an easy way to always find period is you just go peak to peak. So peak to peak is 1.5 minus negative 0.5. That is going to be 2. And period is always equal to 2 pi over b, which means we need to find b. And I can do that in my head pretty easily. Clearly, to get to 2, we need to divide by pi. So I'm going to put pi x. You can also cross multiply this. You can solve that however you like. You should get that b is equal to pi. Okay, next, it hasn't necessarily been shifted because this value starts at the midline. You can kind of tell this is the midline of the graph. But if that's the start and it goes down first, then that means we need to make it negative. So we don't have to do a phase shift, but if we don't do a phase shift, we need to make sure it's negative. If you wanted to do a phase shift, that would be fine. You could just say that the phase shift was this amount, because this is where it starts on the midline and goes up. So that phase shift would be -1. So if you put -1, that's fine. You would just have to leave off the negative in front. So these two are equivalent. Pi x minus 1. But phase shift needs to be in an extra set of parentheses. So far we've got these two options. They're exactly the same. Let's deal with the amplitude. So top to bottom, 1.5 to 0.5, it's a distance of 1. Amplitude is half of that, which means the amplitude is a half. So both of these should have a half. And then finally, it has been moved up because it's not centered around 0. The midline is at 1, so both of these need a plus 1. And either one of these should be a valid answer. But do the bottom one, it's not a bad idea to distribute pi, but it doesn't specify, so either one is an okay answer for this problem. Okay, 29, very similar. The first thing that jumps out at me is that it looks like a cosine. And it looks like a cosine because it starts in the bottom, which actually means it is a negative cosine. So I'm gonna put negative cosine. And then if I draw the midline, it's like right here. It's about halfway through. It goes 3 above that and 3 below. So that's a good midline. But let's first deal with the period. So it goes from negative pi over 6 to 5 pi over 6. So let's see. Period equals 5 pi over 6 minus negative, that's a plus pi over 6. That is just pi. And period is always equal to 2 pi over b. Multiply both sides by b, you get that b is equal to 2. So I'm going to put a 2 in front of the x. Next up, I need to see how it's been shifted horizontally. So cosine normally starts at 0. Mine starts at negative pi over 6. So I'm going to need plus pi over 6 inside parentheses. Finally, my amplitude, I think I mentioned it earlier, but it's 3. The distance from the top to bottom is 6. Amplitude is half of that, which is 3. And the midline is negative 1, which means it's been moved down 1. This is the final answer. And again, just like the last one, there are a couple of ways to do this. This is probably the easiest, so this is what I would stick with. But it is possible that you know it a different way and you still got the right answer. Okay, let's see. So this is asking for the range of the function inverse tangent. So the first thing I would do is I would think about the function tangent. So this is tangent. Tangent has an asymptote at pi over 2, another asymptote at negative pi over 2. And we know that before we take an inverse, and take an inverse means we switch x and y. But before we do that, we have to chop it. So normally tangent would repeat a bunch of times. We're going to ignore that. We're chopping it at pi over 2 and negative pi over 2. So that means inverse tangent, x and y switch. So inverse tangent would look like this, with, again, an asymptote, but this time it's horizontal because x and y are switched. So the asymptote is at pi over 2, and the other asymptote is at negative pi over 2, which means the range is negative pi over 2 to pi over 2. You do not have to draw a picture to get full credit for this one, but I do recommend it because it's easy to get mixed up if you don't have a picture. Okay, number 31 says, find the exact value of the arc cosine of root 3 over 2. Because this is a positive number, it will definitely give us an angle in quadrant 1. Anytime we're taking an inverse or an arc trig function, it will put us in quadrant 1 if it's positive. So if cosine is root 3 over 2, it's this triangle, which means it would give us this angle, which is pi over 6 or 30 degrees. Either of those will be an acceptable answer. I would probably put pi over 6. And it does not have any other values because arc cosine or inverse cosine is chopped. It will only give us a value in quadrants 1 or 2. And since it's positive, it will definitely be in quadrant 1. Okay. 32 says, find the exact value of the tangent of the arc sine of 1/2. So if the arc sine of 1/2 is some angle, here's what we know. We know that the sine of the angle is a half. And we are trying to find the tangent. So what I would do is I would draw a triangle. And in my triangle, I'm going to label my angle. And I know that the opposite is 1 and the hypotenuse is 2, which means that this side is actually going to be root 3. You can do the Pythagorean theorem to find it, or you can just remember 30, 60, 90 triangle. But the tangent of this is going to be opposite over adjacent, which is 1 over root 3, aka root 3 over 3. So you can do this even if it's not an angle on the unit circle. In this case, we know that theta is a 30-degree angle, but we didn't have to know that to draw this picture. You can see we did not use 30 degrees anywhere, and you shouldn't use 30 degrees anywhere when solving this problem. And this is a great example of why you shouldn't use 30 degrees, because this does not give us enough information to actually find the angle. This problem is very similar, except it says that the inverse sine is equal to some angle. And they want us to find find the secant of that angle. And as we know, secant is 1 over the cosine. So if the inverse sine is an angle, that means the sine of the angle is x. So again, I'm going to draw a picture. And I'm going to label my theta. Sine is opposite over hypotenuse, so it's x over 1. And I can do the Pythagorean theorem to get that this side is 1 minus x squared square root. So 1 over cosine is going to be adjacent over hypotenuse, but flipped over, so it's opposite. No, sorry. So it's hypotenuse over adjacent. So the hypotenuse is 1, and the adjacent is root 1 minus x squared. And that's actually the answer. We don't need to rationalize it because it's got an x in it. We usually don't bother if it has an x in it. So we'll just leave it. Okay, 34. 34 says to solve the following for all radian solutions. So I noticed right away that there are two different trig functions. There's a sine and a cosine, but I also noticed that it's pretty easy to just factor them, and that's a great way to separate them. So if I factor out sine x, I get 1 plus 2 cosine x equals 0. And if I have this, then I can just split it into two equations. Sine x equals 0 or 1 plus 2 cosine x equals 0. Sine x is 0. That means that x is going to be 0, pi, etc. This is going to be equal to k times pi. There are ways to write that slightly differently. You could have put 0 plus 2 pi k, pi plus 2 pi k, but those end up simplifying to just be k times pi. 1 plus 2 cosine x equals 0. We can subtract 1. We get 2 cosine x equals -1. Then we divide by 2. We get cosine x equals -1/2. And then there are two places that happens. The first is in quadrant 2. And if cosine is 1/2, that's the short side of a 30, 60, 90. Looks like this. And that angle is going to be, I want it in radians, so it's 2 pi over 3. So x is 2 pi over 3, and then we do plus 2 pi k. And then finally, the next one would be 4 pi over 3. It's the same thing, it's just in quadrant 3. And again, I'm going to do plus 2 pi k. So that is an answer, this is an answer, and this is an answer. And that should do it. Okay, next, 35 says solve 2 sine squared minus cosine is equal to 1. I noticed that there's a sine and a cosine, which I don't like. So the first thing I want to do is swap out sine for 1 minus cosine. And then I'm going to distribute this 2. And I'm going to get 2 minus 2 cosine squared minus cosine x minus 1 equals 0. Then I combine my like terms. I get -2 cosine squared minus cosine x plus 1. You don't have to do this, but I'm going to divide everything by -1 because it's nicer. And I get 2 cosine squared plus cosine x minus 1 equals 0. Then I'm going to use my quadratic formula. So cosine is -b plus or minus the square root of b squared minus 4ac all over 2a. And that simplifies to be -1 plus or minus the square root of, well, that's 1 plus 8. It's going to be square root of 9. So that is -1 plus or minus 3 over 4. -1 plus 3 is a half. Well, -1 plus 3 is 2. 2 divided by 4 is a half. -1 minus 3 is -4 over 4. That's a -1. So I'm looking for where cosine is a half or it's -1. So if cosine is a half, that means I'm in quadrant 1 or quadrant 4. So if cosine of the half, that is, well, does it say radians? It does say radians because it says 2 pi. So that would be pi over 6 and 11 pi over 6. That's where cosine is positive 1/2. And then cosine is negative 1 at pi. So those are all of the answers between 0 and 2 pi, which is what it asked for. Okay, next, number 36 says prove that sine squared times cotangent squared plus 1 is equal to 1. Well, the first thing I'm going to do is rewrite cotangent because it's much easier if it's written in terms of cosine and sine. So cotangent is cosine over sine, and they're both squared. Then after that, I'm going to distribute. So if I distribute, I get sine squared times cosine squared divided by sine squared plus sine squared. And then because these are both multiplied, they will cancel. I'm going to end up with cosine squared plus sine squared, and that simplifies to be 1. For all of these next one, I'm going to need my formula sheet. So let me pull up my formula sheet. You can find it in Canvas. It's under modules. I think I put it in module 2 because module 2 is specifically, well, maybe module 3. There it is, module 3. Module 3 is the one that required the formula sheet, and that will be provided to you on the final exam. So let's go back to what we have here. We are given 1 over 1 plus cosine plus 1 over 1 minus cosine is equal to 2 cosecant squared. The first thing I want to do is get these fractions to have a common denominator. So the common denominator is 1 plus cosine times 1 minus cosine. So I'm going to multiply the top and bottom of the first fraction by 1 minus cosine. And then I'm going to multiply the top and bottom of the second fraction by 1 plus cosine. So when I do that, the numerator will give me 1 minus cosine plus 1 plus cosine, and that is divided by, if I FOIL this, I get 1 minus cosine squared x. And then on the numerator, my two cosines will cancel each other, and I end up with 2. And in the denominator, 1 minus cosine squared is the same as sine squared. And 1 over sine squared is just cosecant. So the 2 will stay, and I end up with cosecant, and that's it. To properly format it, I probably should have left myself a little more space and written it like this, but now I'm finished. Okay, number 38, this definitely will require a formula because we have cosine of 2x minus 3 sine x minus 2 equals 0. And I notice that cosine of 2x is a different angle. We've got 2x here, we've got x here, and we need to make that swap. So I'm going to look at my formula sheet and figure out what cosine of 2x is equal to. And here it is. It's equal to 3 different things. I'm going to pick the last one because I need just sine, because in the rest of my equation, I only have sine. So instead of cosine 2x, I'm going to put 1 minus 2 sine squared x. So 1 minus 2 sine squared x goes in place of cosine 2x. And then we've got minus 3 sine x minus 2 equals 0. Then I'm going to combine my like terms, the 1 and the negative 2, and I get negative 2 sine squared x minus 3 sine x minus 1 equals 0. And again, you don't have to do this, but I'm going to divide by a negative just because everything is negative and it would be easier if everything was positive. But this from here looks like a quadratic, so I'm going to put that sine x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And let's see, that'll simplify to be negative 3 plus or minus 1 over 4. Negative 3 minus 1 over 4 is negative 4 over 4. That's negative 1. Negative 3 plus 1 is negative 2. Divided by 4 is negative a half. So where is sine equal to negative 1? Well, sine is equal to negative 1 whenever y is negative 1 on the unit circle, and that is 3 pi over 2. And then the other question is, where is sine equal to negative a half? And that would be quadrants 3 and quadrant 4. So in quadrant 3, the answer is 7 pi over 6. And then in quadrant 4, it's 11 pi over 6. But that should do it, because it asked only for the answers between 0 and 2 pi, so we found them. Okay, number 39 gives us sine 2x cosine x plus cosine 2x sine x equals a half. As it is written, it is going to be pretty nasty to handle. So I want to look for some substitution that I can make. So let's see. If I go back to my formula sheet, I've got a sine cosine plus cosine sine. Let's see where that is. Ah, there it is. Sine cosine plus cosine sine. Is that what I have? Yes, sine cosine plus cosine sine. That is equal to sine of the two angles added. So if I put this together, this is the same as sine 2x plus x according to my formula sheet. So then this means that we've got sine of 3x equals a half. Well, where is sine equal to a half? That would be quadrant 1 and quadrant 2. In quadrant 1, we get pi over 6. And in quadrant 2, we get 5 pi over 6. And then all we have to do is divide by 3. So I'm going to get x equals pi over 18 or 5 pi over 18. And because it only asked for angles between 0 and 2 pi, we are finished. Okay, number 40 says to solve -2 sine squared of 2 theta minus cosine of 2 theta plus 1. Now I noticed that they're both 2 theta, which sometimes I would try to swap out, but in this case I won't because they're all 2 theta. There is no cosine of theta or sine of theta or anything else of theta. So I can just leave it as cosine, but, excuse me, as 2 theta, but I've got a cosine and a sine. I have 2 different trig functions, which means I want to swap out my sine squared. Instead of sine squared, I'm going to put 1 minus cosine squared of 2 theta. And then we've got minus cosine 2 theta, and then plus 1 equals 0. Then I'm going to distribute this -2, and I get -2 plus 2 cosine squared of 2 theta minus cosine of 2 theta plus 1 equals 0. Finally, I combine my like terms. I get 2 cosine squared 2 theta minus cosine 2 theta minus 1 equals 0. And this is a quadratic, but instead of x, I've got cosine 2 theta, and it's equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And let's see, that will simplify to be 1 plus or minus the square root of 9 over 4, which is 1 plus or minus 3 over 4. 1 plus 3 is going to be 4 over 4. That'll give us 1. 1 minus 3 will give us -2 over 4. That's negative a half. So cosine of 2 theta is 1, or it's negative a half. That means 2 theta, our angle, is, well, let's see. If cosine is 1, we're talking about 0 plus 2 pi k. Or, and I put plus 2 pi k because it says for all radiant solutions. Ah, shoot, I just realized I should have done that here. Yeah, I should have. And the reason is I am missing solutions. It's 5 pi over 18, but it's also like, oh, what else would it be? Hang on. If I divide by 3, I get two things. I either get pi over 18 plus 2 pi over 3k, or 5 pi over 18 plus 2 pi over 3k. And then I just have to plug in different values for k until I'm bigger than 2 pi. So I'm going to start with pi over 18, then 5 pi over 18. That's for k is 0. Then I'm going to plug in k is 1. Well, if k is 1, instead of 2/3, I'm going to make it 12 over 18. So that's also 2/3, but at least I have a common denominator then. So 12 over 18. So let's see. If I plug in 0, I get pi over 18, 5 pi over 18. When I plug in 1, I get 13 pi over 18. That's less than 2 pi, so I got to keep going. If I plug in 1 right here, I get 17 pi over 18. If I plug in 2, let's see, if I plug in 2, I get 25 pi over 18. Still less than 2 pi, so I still keep going. If I plug it in here, I get 29 pi over 18. And I think that will be it, because if I plug in 3 right here, I get 37 pi over 18. That is bigger than 2 pi. So I'm done. So this actually is my full list of answers. Forgot, whenever you have a number in front of your x, you have to do the k. You only get rid of the k when you're finding your final answer. Anyway, back to this other one. Yeah, I have 0 plus 2 pi k. And then where else is cosine 1? It's only at 2 pi, so that's all the ones. But where is cosine equal to negative a half? Well, that's quadrants 2 and 3. It'll be 2 pi over 3 plus 2 pi k, or 4 pi over 3 plus 2 pi k. The last thing I need to do is divide everything by 2, and I get theta is pi k. Theta could be pi over 3 plus pi k, or theta could be 2 pi over 3 plus pi k. And that's what I get when I divide all of my answers by 2. So I'm going to stop there, and we will wrap up with the rest of these problems by doing them in class, hopefully tomorrow. But in the meantime, please email me if you have any questions.